really excited to talk to everybody today about an incredibly important topic as it relates to decarbonization, and that is the built environment. So let's pause for a moment and consider what the built environment is. So it is the homes that we live in. It's the offices we now occasionally show up to work in. It's the schools that we learn in. It's the hospitals that we get treated in. It's roads. It's energy and water utilities that provide us with power and sanitation services. It provides us with an immense amount of value, the room that we're in today. It is also, it is also associated with a significant amount of carbon emissions. So the operational energy required to power this building, and all buildings across the planet require about 28% of total global carbon emissions annually, or associated with. And about 11% are the inputs to the building. So that is the steel, the timber, the cement, the fixtures. That is called embodied carbon, and I'll come back to that in a moment. But that makes up about 11%. So the built environment is associated with roughly 37 to 39% of CO2 emissions in any given year. And our population continues to grow. So last November, we just surpassed 8 billion people on the planet. And increasingly, we are bringing on tens of millions of people into the global middle class every year that are requiring more and better housing and more and better infrastructure. This all requires a significant amount of energy. And that is not even to mention the changes to the built environment, such as we saw during COVID, such as we will need to realize for aging populations. Japan is at the forefront of this. So we're seeing pretty significant changes here. Now, we are seeing early signs of change for the built environment overall. That comes in the form of regulatory pressures to measure, manage, and reduce carbon. And it comes in the form of public sector incentives to build more sustainable infrastructure projects and buildings. And what's important to note here is that the industries that comprise the built environment are incredibly risk-averse and slow to change. So the example that I like to give here in the Bay Area, the Transamerica building took 3 years to construct. The Salesforce Tower took 5 years to construct. That's not even to mention design, planning, procurement, permitting, et cetera. So these are long-term projects that take a real chunk of time, sometimes better part of a decade. And we need these industries to change, and we need them to do so at speed. So you're probably wondering, what are we going to do about this particularly hairy problem? And I will remind you, you were at a conference about climate change and technology. So the answer, obviously, is technology. I work at a technology company. I'm biased. But let me convince you as to the why. The why really is sustainability is, at its core, a data challenge. I'll say that again. Sustainability is a challenge about data. So how do I know this? I manage the carbon footprint of our company, and it's incredibly challenging to get all of the energy data and the concomitant emissions associated with that energy together to be able to report on that. Only by gathering the right data are we able to measure, manage, and reduce our carbon footprint. The industries that we serve are incredibly slow to adopt some of these digital changes, but we're beginning to see that. The design field, very digitized. Construction and building ops, not so much. So there's an opportunity here, low-hanging fruit. And as these industries digitize and go through digital transformation, this problem becomes easier. Secondly, we need to connect all of the players across the life cycle of project delivery, so that we can ensure what actually gets designed gets built. And so here's a funny little secret about the architecture, engineering, construction industry. What gets designed isn't necessarily what gets built. So an architect can design the most sustainable building. The moment that goes to construction docks, the general contractor has different incentives. They are trying to build that building as quickly as possible at the lowest cost possible. And then there is another change of incentives. When the GC hands the keys of the building over to the asset owner, they are trying to maximize the economic value of that building by increasing revenues and reducing costs. So all of these disparate incentives need to be brought together across the project lifecycle. You're probably wondering what this looks like in practice. So how does this actually work, and how does data and collaboration come together to support more sustainable outcomes? So what you're seeing here is Microsoft's campus in Redmond, Washington. I cleared this with Melanie to talk about this story, just so everybody knows. And a couple years ago, they were going through a renovation and retrofit. And they were working with a large design build firm called Skanska. You may have heard of them. And Autodesk was brought in when Skanska was trying to determine the embodied carbon content of the existing building footprint. And we, in conjunction with Skanska and Microsoft, created a tool called the Embodied Carbon Calculator for Construction, or EC3 for short. And you can see the results. Basically, they were able to reduce the embodied carbon, again, those are all the inputs into the building, by roughly 30%. We decided that this was such an important innovation that this needed to live beyond our four walls, so we created, in conjunction with our partners, a nonprofit to house it. And it now lives on its own. It's the nonprofit that runs it. It's called Building Transparency. It is essentially a database of building materials and associated carbon emissions data with that. And so Building Transparency keeps all of that up. It's available to our customers. It's available to our competitors. It's available to anybody in the industry. And it's a great example of how data can lead to more sustainable outcomes. So I've got one more, I think, even more interesting story. And that is the British Antarctic Survey. So this is the UK's National Polar Research Institute. And they actually have a physical space down in Antarctica. It was about 6 buildings. They had reached the end of their useful life. And what they decided to do was rebuild. It's called the Discovery Research Building. And it's crazy, the idea of building a building down in Antarctica, the extremes of construction in such a place where there are very few energy and material resources. So they had to optimize for everything. They had to optimize for material reuse, using the inputs from the old building. They had to optimize for the new materials in the building. They had to optimize for energy because there's so little energy generation down there. And what you see here is the result. They were able to reduce the carbon footprint by hundreds of tons. They were able to do so by bringing everybody together, over 100 collaborators across the design, build, asset management space. And they did so from 15,000 kilometers away. So I want to wrap these examples on what's next. So what you're seeing here are conceptual design models that take into account all of the inputs that are associated with energy consumption and subsequent carbon emissions. So that is daylighting, sunlighting, solar panel placement, facades, energy consumption, number of units, heat zones. The ability to optimize all of these various inputs into a building envelope and to make the best and most sustainable decision is a huge opportunity. The thing that the real innovation here is showcasing the trade-offs. If you have a building that you want to provide more insulation for heating, that subsequently results in a higher embodied carbon content. And so in order to manage and optimize for those trade-offs, you need all of this data. This is the future of AI and algorithmic tools for the built environment. It's very exciting. We're just at the outset of it, and I'm happy to talk more about it, but it's going to help us solve these sustainability challenges. And once you've solved for carbon, you can attack other problems, like water. You can attack issues around waste. By some measures, construction waste is roughly 30% of total landfill in the United States. You can also optimize for labor shortage challenges. We have huge labor shortage challenges in the construction space. So I think that these new tools and optimizing the data are going to let us do a host of new and interesting things in the built environment space. So I will leave you with this. We need to completely rethink how we design and build our wonderful built environments that provide us all these services and benefits. We need to digitize the workflows completely, and we need to bring together all the parties, the designers, the engineers, the construction professionals, the asset owners, such that they can ultimately fulfill the sustainable commitments that they've made, that their municipalities have made, that global governments have made according to the Paris Climate Agreements. And we will only be able to do so via data and collaboration. So thank you very much. I hope you've learned a bit about the built environment. Yeah.
That was great. I just want to ask one question.
One
question. Just one question. This is very optimistic talk. Data and collaboration can do a lot.
Yes.
But what is it that you are afraid of? Like, what holds you back? What keeps you up at night in terms of what could go wrong instead of the case you just laid out, which is like how to do this right?
Yeah. It's a great question. That was very optimistic. I hope people leave feeling optimistic, but thank you, Dan. The big challenge here is around regionalization and data federation, right? And so Europe has one set of laws requiring this. The UK has another set of laws encouraging these various initiatives around the built environment. And so if we have to build to each of these specific laws, I mean, it gets, for those of us who live in the Bay Area, it's pretty crazy around here, around like what you build. That is the thing that can really really detract from where we're trying to go. It would be great if global governments came together or municipalities came together and set the rules to a certain extent. So the thing that keeps me up at night is public sector leadership in this space. And it's one of the reasons why we as a company go to the COP, Paris Climate Agreement annual gathering, because we want to hold our public sector leaders accountable for helping create the operating environment that's going to enable all of this to happen.
Yeah, and that's the level playing field you need, and that's going to incentivize all of the actors up and down through the supply chain.
Exactly. Yeah.
It was a great talk.
Thank you very much. Appreciate it.
Thanks so much.
Yeah. Thanks for the opportunity.
Thank you.
Thank you all.